Hello everybody. Good morning, it's Saturday and I'm doing some coding. We have this length of last word problem, easy problem, and honestly I kind of like to just do a lot of easy problems, right? And you don't just find a solution and then move on, right? I like to really beat it into the ground, find the best solutions, think through them. What's the complexity of this solution? So this is going to be fun. I have a few different solutions that I want to look at and talk about. And I also think actually that in like an interview setting, it's actually more likely that you're going to get some type of easy kind of problem like this, just because it's such a small amount of time that you have and you want to talk about all the things and you don't really have a lot of time for writing, going through a more complex solution. So just keep that in mind, it can be fun to do the medium hard problems sometimes, but they're really sometimes just more time consuming rather than like intellectually more things that you need to think about. So anyway, let's talk quickly about the problem, right? You're given a string that has some words which we're defining as separated by spaces, and you want to find the length of the last word, right? So moon, we would return 4. This one, the last word is world, so we return 5. Okay. So I went through this and first did this in NodeJS, TypeScript. Even though I'm a massive Rust fanboy, I just find TypeScript to be a really nice, easy to read, easy to conceptualize kind of what's going on type of language. So we have our function, length of last word. It's taking an argument s. Since we're in TypeScript, we could say this is a string. We're trimming off the white spaces on the end, right? For example, this example 2, if we don't do that, then we could mess up our answer. Then we're going to split on spaces in between here, right? And that's going to give us an array of strings. So if that length is greater than 0, we're going to take the last one and then the length of that. Otherwise, if the words of length is 0, then we'll just return 0. And so we can see it takes 1 millisecond to run. And sometimes you're going to get all different results, It could be times here, which is a little weird, but you can see the memory takes about 54 megabytes. And even something like this, most of this memory is probably just used by the underlying node runtime, right? Not really this function in particular. So now let's think about what is the time and space complexity of this function, right? Okay, so trim end is going to scan the string once and remove the trailing white space, right? So that's going to be, worst case, O of n, where n is the length of the string. Split, same thing, right? It used a regular expression to split the string here. We're going to iterate through the string once, and worst case, we're going to have to go through the entire string, so that's also O of n. Then just this part of it here, accessing the last element, accessing from an array is just O of 1, so that part of it, line 3, is O of 1. And so we basically add them together, n plus 1, as we go to infinity, can simplify to just O of n, right, for the total time complexity of this O of n. And then if we think about space complexity, right, we're thinking about which memory that's allocated. In Node, it's kind of hidden from you, right, what's happening, but actually when we do split, we're creating a new array of substrings, one for each word, right? And each substring is a new string object that's stored on the heap. So worst case, all these characters separated by single spaces will be O of n, extra space, right? So space complexity of this is also O of n, okay? Okay, now I want to take a look at Python solution. And this is pretty similar, right? So we have our class defining our function on that we're also calling length of last word. This takes the self object and our string input here. So we're doing the similar thing. Split this automatically ignores the trailing white space and splits on spaces, so you don't have to pass any arguments into that. And then we just return the length of our last words, right? We have this goofy -1 index syntax in Python, but that basically means count from the back of our array and bring the first element. If we have some words, we're going to do that, otherwise return 0. Okay, so this one, potentially a little bit faster, a little bit better memory. You know, again, it's probably just the Python runtime that's using most of this memory. So if we think about what's the time and space complexity of this one. So split basically scans the length of the entire string, creates a substring for each word, right? Same as node. That's also going to be O of n. Has to go through the entire string. Then again, we have our indexing, reading from an array is O of 1, just like it was in node. So again, our total time complexity here is O of n. Thinking about the space complexity, s.split, same as node, creates a list of substrings, and so we can say that our total space complexity here is O of n. Okay, now let's get into the good stuff and switch over to Rust. Okay, here we have our impl block. We're implementing the function length of last words for our trait solution. So we have our s input, right? That's going to be a string here, and then we're returning our 32-bit integer. So this is actually just the first Rust solution that I created on my first pass through this. And so what are we doing? Kind of similar to the other node in Python. We're splitting on the space character. Then we're mapping over them and converting it to a string, basically memory allocated string. And then we're filtering out the empty string, and then we're collecting that all into a vector of these strings. Then I'm calling this words.last, right? Get the last one, and that's going to give us an option. So we do this if let to basically unwrap it. If we have some word, then we're going to try to get the length of that, just basically blow up and panic the program if we can't read a length of that. Should never happen. So unless we have some crazy insane input or just so big that we can't read it. Otherwise we return 0. And notice there's no return keywords here because we're not using semicolons. We know that this is the return value of this whole block here, and then the 0 is the return value of this whole else block. And then if let is actually an expression, so we know that whatever branch it evaluates to, these things that are returned from there will be returned by the whole expression. So also, all these took 0, 1 millisecond, pretty much nothing in terms of runtime, so it's hard to compare across languages for this particular example. And even memory is hard to compare across languages. Yeah, Rust did take 2 megabytes when Node took 55 megabytes. Again, that's more of the underlying runtime. But that does say something about, if you're running on a Raspberry Pi or something where you really do need to conserve the amount of megabytes of memory, then probably NodeJS is not the right thing. And that's one reason why Rust really shines there and why I'm getting into embedded development with Rust and using it for those kind of projects. But anyway, I'm getting sidetracked. Let's think about the time and space complexity of this solution here. So the split empty string splits on every string, every space, produces n substrings, and As we go to infinity, it just becomes O of n. And then mapping basically is another pass through O of n. And filter is another pass through O of n. And then collect basically copies all of these strings and heap allocates them. But we're just talking about time complexity right now. Last, again, it's basically that reading the index of an array vector here in Rust case. So that's just going to be O of 1. And then reading the length is also O of 1. Okay, so we have this O of n plus n plus n, which as we go to infinity simplifies to just O of n. Okay, so that's the time complexity here, O of n. Space complexity. So our vector of this capital S string holds all the words, right? And each word is a newly allocated string. And in the worst case, think of the worst case as a string with no spaces, and then it stores the entire string again in memory in the vector. And then it really is O of n because there's n characters and all n of them are being reallocated to a new string. Okay, so this is, O of n and O of n, okay? So this is correct, but it does kind of waste memory by keeping all the words in memory instead of just finding the last one. Let's look at a different solution here. Also in Rust. Okay. So we have this split white space function. Split white space creates an iterator that's basically like a lazy scan through the string. And so under the hood, Rust iterates through all of these strings to find the last word. And that's basically O of n in terms of time complexity to go through that. And then we have our dot last, it's just O of 1. Counting here is going to be m for the number of letters in that word, m, right? Where n was the number of characters in the entire input string, right? So we're going to have to pass through the input string once to get the words. Then you're going to have to pass through the word to get the count. Okay, so that's then n plus m, which as we go to infinity, n is bigger, so it just becomes O of n. But the space complexity here is interesting, right? Because we split white space, it's lazy evaluated, it doesn't need to allocate any strings when we're doing this. Last only keeps a reference to the current candidate word, string slice, and then charge.count iterates over the characters without storing them. So there's no heap allocation here at all beyond just like the input string. Okay, so then space complexity here is O of 1. Okay, so for the solution, time complexity O of n, space complexity O of 1. And that's kind of the interesting thing that I like about Rust, they call it like zero cost abstraction. So TypeScript and Python, it's nice to have this like cute, simple syntax that's easy and you don't have to think about memory allocation under the hood, but it's happening whether you think about it or not. And sometimes when you are thinking about it, it's hard to improve it because the syntax that you have doesn't really give you that control in other languages other than Rust. But, so there actually is a separate solution. This one is kind of interesting, and this kind of thinks about the problem in a totally different way. We're kind of doing a pointer scan through the string reverse, right? So we create one mutable variable here called len. Then we have our variable c that we're creating. We're splitting it into characters, the entire string. We're going to reverse through it. If c is not equal to a space, we're going to increment 1. Otherwise, if length is greater than 0, okay, so if we did hit a space and length is greater than 0, then we're going to break out of our for loop, and then we'll just return the length. So for this one, chars chars here creates an iterator over our just Unicode scalar values that you have there in the string. And then rev makes it traverse backwards, and we don't have to eat any time complexity cost for that, so that's good. So the loop's going to scan through at most n characters, where n is the entire string, and as soon as it finds the last word trailing space, then it breaks early. Okay, so the best case actually is O of k, where k is the length of trailing space plus our word in the end of our string there. And the worst case is still a string with no spaces, which would be O of n, right? So time complexity is still O of n because of that worst case. Space complexity though, we still only have one counter variable len, no allocations, no intermediate slices or allocated strings, uppercase S strings, no vectors here. So space complexity of this one single number is just 1. So here we have arguably the most optimized solution, because space complexity is just O of 1, and time complexity has that best case that's less than O of n, or O of n at the worst case. And to be honest, this kind of just walk through the string backwards you can do in Python and TypeScript also, and you'll get that O of 1 space complexity. And so that's nice, and that's something that you could say about that Python and Node are competitive with Rust. But you do kind of have to do it in this low-level pointer logic way, where Rust actually gives you that elegant syntax way of getting O of 1 space complexity, you know? So something to think about. Trade-offs and different ways to optimize your code, your program, your logic. Yeah. So let me know in the comments which solution you like the best. If you have other ones, have more questions, suggestions for other problems that I should do. And that's all for now. See you next time.